Hello. Um, Today we have Leetcode 131 Palindrome Partitioning. And the question reads, given a string S, right? Partition is such that every substring of the partition is a palindrome and return all possible palindrome partitioning of S. So basically, we have to divide our string into substrings, which are all palindromes. And you can see from example one where we have AAB, right? If you partition the string by taking its distinct characters, right? Every distinct character or every single element is in itself a palindrome. So this suffices. Also, AA is a palindrome. So this suffices. And then B also, right? It's a palindrome. So this is a good answer for here example. Same thing here. And then you can see from the constraints, right? We have 1 to 16. So it's kind of odd for a normal equal question, except this is not a normal equal question. This is a backtracking question. And the hint is here, right? Return all possible palindrome partition. You're supposed to give every single way of doing it. And usually when you want every single way of doing something, right, then it's going to be brute force. And brute force in this case is backtracking. So basically, all I will want to do is to divide the string into multiple substrings. Check if each substring is a palindrome. If it is, then I add it to my list, where I'll have something, a list taking it to my probably DFS function or backtracking function. And then from there, if we terminate the string, right, then I'll add my list to the result. The result is supposed to be a list of strings in Java. So without further ado, let's just get into the coding. I want to create our result, right? Basically, I just want to call that DFS, right? So the DFS is going to create a string S. It's going to need a new list, right? A list that will add in due time to our result, and then again, we need our result, and also we need an index. Basically, a starting index that we use to go through string S and gives us an idea of if we reach the terminating point or not. So if our DFS is done, we want to return our result basically, right? And notice that our DFS will be using a different function, which is palindrome, because I have to check if our string is a palindrome. So I want to write the is palindrome function first, because I think that it's just simpler if I do that. So I want to make the code faster, so I need a car array. And then just normal ways of checking what palindrome is. Excuse me. Right, so while our start is less than or equal to our end, right? So normal palindrome, if the array of the start is not equal to that of the end, right? Then we know that it's not a palindrome, so we're gonna return false. Otherwise, just increase start and increase and basically, decrease and basically, right? And then we return true if our while terminates. Okay, cool. Now the DFS function basically just a very basic backtracking function, right? And our DFS is taking a string. It's also taking a list of string, right? We call it list here, and a list of strings. And that is our result. And then this is a starting index, basically, right? So if our starting index, sorry, if our starting index is at the end of our string, right, then we know we've terminated it. So we just want to add whatever list we've built till then. So it's s.length, right? If so, and what we want to do is not say result plus I'm gonna add a new array list of our list, right? After that, I want to return so that in case a star that exceeds s.length and stuff like that, those will be taken care of. We don't want to index out of bounds errors, basically. Okay, So just want to write a simple for loop, and then the for loop will start at starting index. Initially, it will be zero, right? And then we go from a starting index to the end of the string, basically, right? Again, guys. Um, right. So we are looping through the string, and then we want to check, right? If we want first to extract our substring, right? So say our substring of s is what s dot substring, and it's going to start at the starting index, wherever our starting index is. And as the key is expanding, right? So the key's value is going to be like a way of expanding the string for all possible combinations, right? So the key and plus one, or plus one in Java because of how the substring works, substring method, you have to go um to the point where you want to end plus one, right? That's why I have key plus one basically. So string, this is it, and then we want to check if it is a palindrome, right? So if it's a palindrome, sorry, right, if str that we have is a palindrome, then fine, we can now add it to our string, sorry, to our list, right? And not just that, we can do a DFS on the rest of the string, right? So DFS list, result, and then start. Now the new start position was k plus one, right? Because we ended at k, so we want to be k plus one, right? The next start. And if that doesn't work, then we want to backtrack, right? So to backtrack, we'll just remove what we just added, basically. So list dot size minus one, right? Basically, this is the function. The interface has kind of changed on Leetcode, so we keep changing it. Let me see. So we pass the first four tests, right? We have A, B, and these are all the possible changes. So it's going to be expanding because of the for loop. The key starts at then starts and keeps expanding for all those kind of options, and try and get substrings that are palindrome. And if they are, right, it's gonna reach the end, and then we add to our result. So we have A here, CAB, right, and then I think CAAB, and basically here you see for just for this short string, right, the number of possibilities are so many. So that's why we have it very low, and also the runtime is crazy. So what is it going with the runtime? Well, for each substring, we're going to check, right, if it is a palindrome. Now, this goes to be a O of n operation in the West time, where n is the length of our string, right? So in the worst case scenario, this is going to be O of n. And also at DFS, we have two choices to make because it's a basic backtracking. Right? We either add to our list or we remove. So these are two decisions, right? So it's going to be, if we have n things and I'm making two decisions for each of them, right? It's going to be 2 to the power n decisions. So in the end, it is n times 2 to the power n. That's our runtime. Space complexity, not really an issue with our results. It's going to take as many palindromes as we give it. So say we have n palindromes, right? Then our space complexity will be off n basically. Um, so I think that is it, guys. If you like it, let me get some feedback. Please subscribe, and I'll see you guys in the next one. Peace.